Okay, so in chapter 3 in statistical measurements, so far we have covered measures of center, measures of variation. Now we are going to focus on measures of position. So basically by end of this section, end of this session actually, you should be able to understand what is actually percentiles and what is quartiles, and at the same time, what do we understand by Z-score for a data sets. And in every chapters, after the problems and all the explanations, you might get one Python program that help you to calculate our measures of these positions for a data sets. So let's go one by one, like measures of position. So basically, this is going to indicate the relative location of particular data point. So particular data point is actually, lying where it's in the first 25% or is in the first 50% or is first 75%. So, our particular data point, actually their relative location, actually we're trying to find. So common measures of positions include basically like we have percentiles, quartiles, and also the Z-score that we are going to cover here. So let's focus on the percentiles. What do we understand by this? So basically, this percentiles mean it going to assess and compare the distribution of values in the data sets. That means it's going to assess your all the data points, all the data values, and also compare the distribution. So we will also go deep, but before that, percentiles show the position of a specific data point. That means, let's say you have some numbers, different numbers. So a specific one number or 10th number or 5th number, actually, what is their position? In the entire data sets. So a percentile shows the percentage of data points that fall below a given value. That means we are saying that, okay, these 4 values are less than 5. Something like this. So here we have example to make it sense, like a stock market mutual fund might report that the performance for the fund over the past years was 18th percentile of all mutual funds in the peer group. So again, try to focus on this example, like a stock market mutual fund report that performance for the fund over the past years was the 18th percentile of all mutual funds in the peer group. So what is the interpretation here of it? Like, the fund performed better than 80% of all other funds, right? That means here 20% of the funds performed better than this particular fund, right? That means my fund performing better than 80% of all other funds. That means 20% of the funds actually performing better than this particular fund. So this is the actually thing that, a certain position, certain percentiles that we are going to cover, that it's going to actually lie. So here, one thing we calculate. So how we actually calculate for, the calculation of the percentiles. So what are the steps? So remember, so it's steps to find the percentile. So here, first one is order the data set from smallest to largest. So far in measures of center, in measures of variation, so far what we did, always we actually sort our data from smallest to largest. So this is the very common thing that actually every I mean, these tools, every statistics tools tries to, I mean, imply or tries to follow. Otherwise, these methods will not work that much. Second thing, in programming, that's why you will find that sorting problem, one of the I mean, important problem even in any exam or any, I mean, any interview sessions. Second one is the count the number of data values in the data source. So total count of number. And then locate the measurement of interest. So we are actually explaining it later with an example. Like, let's say, count how many data values fall below the measurement. So count how many data values fall below the measurement. That means, I mean, you have find the locate measurement here. That, I mean, for of interest. I mean, who actually wants to find what percent is, and then you need to count that. Okay, after maintaining this that percentage, what are the values are actually below of that, and then the percentile of for the measurement is calculated. So percentile for the measurement is calculated as like number of data values below the measurements, number of data values below the measurement, and total numbers of data points, and then multiply by 100 to get is as is percentile or percentage like this. Now, just give you one simple example here, then I think it will be more clear to you that what is actually the percentile. Let's say there is a problem like the following ordered dataset represents the scores of 15 employees of an aptitude test. So let's say there is a test, like very simple test, and 15 employees got marks. But now look, here is the number 3, like determine the percentile for employee who scored 88 on the aptitude test. So here find the third point in the steps of to find the percentiles, like locate the measurement of interest. So locate the measurement of interest, that is the actually same thing, like determine the percentile for the employee who scored 88. That means you need to fix an interest that you want to check. Let's say you want to check, okay, in this university, or okay, in our classes, who are actually, I mean, how many percentile actually below 3.25 CGPA. So the same questions you can ask. So here, just our question is, okay, determine the percentile for the employee who scored 88 on the aptitude test. So there are 15 data values in total, right? And there are 10 data values below 88. So remember the step number 4, like count how many data values fall below the measurement, right? So whatever the measurement you have picked, you need to count that, I mean, how many data actually lies below that measurement. The same thing we are doing here. Like we have found that 10 values are below 88. So now we got our point, like number of data values below the measurement, that is 10, and total numbers of data points, then 15, and then 100%. So this is the answer, like 67th percentile. Okay, 67th percentile. So that is the answer actually, like determine the percentile for the employee who scored 88. So now quartiles and their relationship to the percentiles. Let's try to understand the quartiles and their relationship to the percentiles. So look, percentiles divide data into 100 equal parts. Like, so that's why here you are dividing your number, I mean, your denominator is the total number of data points. But if I see, I mean, if you if we talk about the quartiles, quartiles is not same. Quartiles divide our data into 4 equal parts. 4 quarters, you can say. 25, 25, 25. But to find the quartiles, so what we can calculate and what are the steps? Remember, Q2, Q1, and Q3. If we find them, then we can get it. So first of all, we need to do one thing. One thing means we need to find the median, middle value of the entire data sets to find the quartiles, right? So find the median, or that means, so from, let's say, from your entire data set, you divide it. So it's something like this. I don't know, like this one, take green, yeah, green. Let's say you have a data set something like this, and you are dividing it by, find the median. So median should be in the middle, isn't it or not? Okay, so median should be in the middle, like this. So this one, actually, you can say something called Q2. Okay, now, so we divided our entire data sets in 2 parts, right? Now find the median of the lower half, like below Q2. So I mean, now we need to find the middle of this, the first portion or the lower portion, all the below Q2. What term you can use? But first I'm trying to understand that, okay, this is the middle, right? So this we are calling that, this is called Q1. Q1, right? So here, and oh, okay. So one thing that that I need to mention here, as you are doing online class, I hate online class, and I don't feel, I mean, in short, আমি আসলে অনলাইন ক্লাসে খুব একটা পড়ায় শান্তি পাই না, so that's the problem. And another thing is that I cannot see your face. At the same time, I don't know what are you doing. So one thing I want you from you all, that you will take a short notes that I'm going to describe, and of course, if there is any line, any points, anywhere you get the confuse, you get some questions, or you can raise hand, so I will discuss about it. So don't feel and don't sit like idle, because these are the important topics that you must get questions from your final exam or class test. So and these are the topics also very interesting. I don't know, I mean, how much interest you are getting or not. As you cannot see me and I cannot see you, that's the problem. But still, as you know the situation, for the one class, just try to be sincere and attentive in the class. Okay. So next one is to find the Q3, like find the median of the upper half. Now in this upper half, median of the upper half, like Q2, right? So it's now you're finding the median above Q2, right? So let's pick another color, like, yeah, this one. Now maybe this is the middle, right? So this one we are trying to say, this is called Q3. Q3. Okay, so now we got our 3 quartiles, I mean 4 quartiles, right? Now 1, 2, 3, 4, 4 quartiles we are actually getting. Now those datas are below Q1. They actually inside the 25%. They are in between the Q1 and Q2. They actually lies in between 50%. They lies who actually Q2 to Q3, they are 70%, 75%, and after the Q3, they're actually more than 75%. And if you remember, I mean, in chapter 1 or chapter 2, we showed you Python library like pandas, discrete function that actually give you these sorts of percentiles. I think you should remember it. Okay. So, okay, next. Okay, so I mean, this visualization was there. Why I was trying like that. Okay, so here actually you see that quartile percentile correspondence. So here Q1 25% percentile, Q2 15% percentile, Q3 that is the 75% percentile, right? So I think you got this point. So now and of course you will share your short notes by what time is it? 6:03. I mean, you will share your short note after the class by 4:30. And share, you must, and always just share one page. Just write your ID and name and take a snapshot and share it by 4:30. After 4:30, submission is not allowed. And I think who is a seer, I forgot the name, but both male and female seer, please collect
Hadi bin Azhar, sir.
Sadi bin Azhar and maybe Sanjida.
Yes, sir.
So, I mean, within 4:30, who will actually submit the class notes, you will just consider them. After 4:30, you will not consider them, and share the IDs, submitted IDs. So female seer will collect the female students' information, and male seer will collect the male seer information, and you will share it after the class, right? After the 4:30, you will inbox me regarding that. And remember, these will, I mean, affect your class test score. So don't forget to submit. Okay, so now here we are finding a problem that is called uh, 3.11. So consider the following ordered dataset, which represents the time in seconds for an athlete to complete a 40-yard run, right? So here, I mean, as it is sorted, so what will be the Q2? What will be the Q2 value? Which one? Can you count how many data points are here? Or who is in the middle?
Here is 11 datasets.
11 data sets. So who will be in the middle? Seven 7.1 or 7.2 or 7.4?
7.2.
7.2. Great. Okay, fine. Now this is our Q2, right? I mean, I'm just mentioning 2. I'm very bad at drawing 2, and at least using mouse or without mouse, just the thing. Now we need to find the Q1, right? So how we'll find the Q1? Here we have how many data points? 5, right? So here it will be 63. That is 1. And here we have 5. That is 79. So as much as is simple. So, we understand the quartiles values, right? So now the problem is uh, like interquartile range or IQR. So difference between the third quartile Q3 and the first quartile. That is actually the IQR, interquartile range. So remember this interquartile range, one of the important topic for your exam. So difference between the third quartile and the first quartile. So that is called IQR, Q3 minus Q1. So this is going to provide some measures of variability that excludes outliers. So here is the important term here, like we got 1 point. We got one point, like how we can exclude outlier. This is the point. So how we can exclude outlier? Who is helping us? These IQer. Okay, these IQer. That's why quartile is very important to understand. So now I think you got the dots. You can connect it now, right? So what is the purpose of this? Let's say quartiles and IQer can be used to flag possible outlier. That means you can flag those data points, their outliers. So we will make a flag to them, right? So we apply IQer method to get the possible outliers in the dataset. So last time I mentioned about the IQer, Z index, something like that, but I think you didn't get you didn't connect the dots. But this time I think you get the points, right? That there are some methods are there. Those basically help us to. And previously in trimmed mean, you got one idea, right? That how we can remove the outlier. But that is a very basic thing, or no one basically use. But this IQR method, one of the best applicable methods and best methods to actually get the the outliers, the possible outliers. So how to detect outliers? So now we need to understand it, how to detect outliers, how to detect, from a data set actually. So here, some steps like calculate a lower and upper bound for outliers, lower and upper bound for outliers. So first you need to calculate the lower, a lower and the upper bound. Like in trimmed mean, can you tell me to here we are finding the lower and upper bound, right? But in trimmed mean, what help us to trim? Anyone remember? Are you sleeping? You got my questions? Like say in trimmed mean, we also trimmed value from lower and upper, right? But
Yes, sir.
in that case, what we use, that what percentage we will delete, how we use, or what we use actually? Some certain percentage, right? Around 10 to 20. Can you remember it?
Yes, sir.
Okay. So now that 10%, 10 to 20. For what? For this trimmed mean. Like, so look here, sometimes it happens that some outlier will remain, or maybe you're going to delete some those who are not outlier, you're maybe delete based on this. So there's a problem with this. Like, so we are not going to follow this one, right? Because there is a problem. So one of the methods that we found that IQR, first we need to calculate the lower and upper bound. So this lower and the upper bound. So how we can calculate it? Any data values below the lower bound. Oh no, so this is the interpretation. So any data values that is below the lower bound is the outliers, and any data values that above the upper bound, that is outliers. So now what are the formulas that used to help, that used to basically find this upper and lower bound, okay? Okay, so upper and lower bound. So here is the formula here, like low bound for outliers. So this is the formula. And for the upper bound, this is the formula. So here you see that, Q1, minus 1.5 into IQR, and Q plus equals 1.5 into IQR. So what actually it means, let's try to understand first. So maybe this will be our last topic for today. So let's see. Okay, so here, example 3.12, problem, let's say calculate the IQR for the following 13 home prices. So here we have 13 home prices, and determine if any home prices values are potential outliers, and data values are in US dollars. So these 13 data points, 13 values are representing home prices in US dollars actually. So here's the solution, like what are the data set, what are the data from smallest to largest. So this is the first thing that we'll do. We will sort our data. And remember, in exam, you might get 10 data points or 15 data points or 20 data points. So you need to practice that, how fast you can sort this 10 or 15 or 20 data points by your hand. Okay, so don't take much time to sort 10 or 15 or 20 data. You can watch a short video for short techniques for sorting in by hand, in short. Okay, so next is here, after the sorting, as it is 13, of course, 13 means what? Seventh value is the key one, right? 1, 2, 3, 4, 5, 6, 7. So Q1 will be this value. Seventh prices will be your Q1, right? Now for Q1 like here, let's say 1, 2, 3, 4, 5, 6. So here are six values. Six values are there, right? So you will pick this one and this one and divide it by 2. So this one and this one and divided by 2. So now this is Q1, right? And here, after the Q1, here also you have six values like 639 and 659. So 639 and 659 will be here. So this one is our Q3, right? So we find the Q1, Q2, and Q3. Next point is calculate the IQR value. IQR value. So what is the IQR value here? Like, we know that Q1 minus Q3, or Q3 minus Q1, right? So here Q3 is 649,000 minus Q1 308,750. So now you got the IQR values. IQR values. Now use the formula that we actually showed here. So now following this formula, if we actually put the values on this formula, now we will get the lower bound range is minus 201,625 and upper bound range is 1159375. As there is no negative numbers, so in lower bound we are not going to delete anyone, right? That is the ultimate interpretation. But as upper bound is 1159, here, we will delete those data points is actually greater than our this upper bound, upper range. So remember, these are the limits. This is the lower limits and these are the upper limits. So now that interpretation, like the lower bound for outliers is minus 201, 625. So no home price is less than minus 201, 625. So no outliers are present for the lower end of the data set. And the upper bound for outliers is like 1159375. So the data value 5500000 is greater than the upper bound of our mentioned range, right? This one. Therefore, home price, this will be our potential outlier. So this is the way actually how we actually find the outliers. And remember, this math is very important in your class test or in your final exam. So this so far, the IQer. So this is one of the, one of the big problem. So I don't know that you got the point or not, but if you have any query, you can actually ask. Okay. So one last point that is called Z score. This is very simple, but this is one of the method that basically help us to measure the position of data value in a data set. So measures the position, right? So represent the number of standard deviations by which a data value differs from the mean. Look, remember last class we told you that how variance, if still there is mean is same from two different data sets, their mean is same, but still there might be a variations, and that variations matters. Because variations tries to get the insights of the internal relations of the entire data points. And we know that standard deviations or variance is one of the method that basically help us to actually understand the internal relation of each data point, that how much they vary from the mean, and how much deviate they from the mean, right? So that's the thing, that's the value actually we help us to identify the positions. So here Z score is depend or denoted by Z, and formula is something like x minus mu. So x is the measurement and mu is the mean, and divided by the standard deviation. Okay, so for every data point you need to calculate it. Let's say for single you have 10 data points, so your 10 data points is actually x, right? So you are subtracting your each data points from the mean and divided it by standard deviations. So here some more insightful things like key points measurement is below the mean. Z score is negative. So measurement is exactly equal to the mean. Z score is 0 and the measurement is above the mean. Z score is positive. So what it means actually? So interpretation, let's say a Z score of 3 would indicate a data value that is 3 standard deviations above the mean. So here basically we define some numbers like 2 or 3, and those values actually let's say we are getting a Z score, and those values are actually less than Z score, they are outliers, and greater than the Z score, they are also the outliers. So let's try to solve here actually we showed you the only finding the Z score. Like for the home, the X value is the home price 27000, and the mean is something 350000, and standard deviation is also given. And here we calculate the -2. So now we will calculate each of the data points Z score, and we will delete less than -2 and upper than -2, right? So in the next class, I will show one math regarding this Z score. I think you will get a little bit familiar with the points. So far we are done for today. Feel free to ask any questions, any problem that you actually face to understand. Let me know.
স্যার আপনি শর্ট নোটস সাবমিট করতে বলছেন, এটা কি ক্লাসরুমে সাবমিট করব?
No, in the WhatsApp group.
ওকে, থ্যাংক ইউ।
the WhatsApp group.
স্যার শর্টকাটের ওখানে কি নাম আর আইডি লিখে দিব?
Just name or ID, one page short note. Just put on your name and names and ID, then share it here. Okay, attendance, right? Section D, 15 plus 3. Okay, so still number 1, Saiful Islam Tanvin present.
Yes, sir.
Rijona Khanum,
Yes, sir.
Rijona present. Sinthi,
Yes, sir.
Promi,
Yes, sir.
Shakira, Shakira present. Ishrat Jahan Iba,
Yes, sir.
Russell,
Yes, sir.
Abir,
Present, sir.
Badhon, Rimon,
Present, sir.
Sadi bin Azhar.
Sir, sir,
Yes,
Badhur
sir.
present.
Okay. Yanish,
Present, sir.
Rafil,
Yes, sir.
Rifat, Ontim,
The present, sir. Rifat.
Wahidur Rahman. Rifat
Yes,
present,
sir.
right?
Yes, sir.
Azim,
প্রেজেন্ট স্যার।
Mithila,
Yes, sir.
Sanjida Yasmin,
Yes, sir.
Ishrat Jahan Shoma,
Yes, sir.
Al Nur Muhammad,
স্যারও ছিল, ইলেকট্রিসিটি চলে গেছে।
Shaun, Shaun is present. Sabbir,
Sir.
Present, sir.
Rafin Al Hassan, Shumona,
Yes, sir. Sir, Afin ছিল।
Sir,
Maybe
I'm
or
present, sir.
electricity.
Sir, I'm
Shakira
present, sir.
present, Rafin present.
Sir, I'm present.
Only absent is Shakwat Hossain Shaun. Or he was also present. Shakwat Hossain Shaun. Anyone notice?
রেডিও বোরকা পরো, তুমি বোরকা পরতে পরতে তো আমার
Okay.